a few more examples of being able to work with these logical equivalencies. We have not P and, or not Q, or not P and not Q is supposed to be equal to not P. So let's see if this is valid or not. We always want to try to work inside the parentheses if at all possible, but in this case, it doesn't look like anything simplified. In other words, nothing to use De Morgan's law on, nothing to associate, nothing to be able to double negative with. So let's go ahead and use De Morgan's law right here to start with. All right, so and what you might want to do is there's a worksheet that you can print out, and it looks like this. So that way you might have these off to the side. So that way while you're watching the video, you can just follow along. Now I'm going to flip back and forth between the two files, right? But the first thing we're going to do is we're just going to use De Morgan's law. And usually De Morgan's law is a good place to start. De Morgan's law says that we're just going to take and distribute the negation that's on the outside of parentheses, and then we're going to flip the quantifier. So this is going to be equivalent to not P and not Q. All right, so that's one set of parentheses. I'm just going to use brackets to delineate them. Or the other part is want to stay the same, not P and not Q, and that's supposed to be equal to not P. All right. Justification is De Morgan's law. All right. So next step, well, I think the next step is pretty obvious. We're just going to use a double negative. So that's going to be not P and Q. And now we can just use one level of parenthesis. So I'll just use a regular parenthesis in this case. So not P and Q, or not P and not Q. And that's supposed to be equal to not P. And that's our double negative. All right, now this is a tricky part, because what we're looking for is we're looking for a pattern of and, or, and. So let's go to our sheet with our basic logical equivalencies. And we have a pattern of and, or. We have a pattern here of and, or, and. And so what we're going to do is we're actually going to go the other way. And we're just going to take this and just make it look this way. All right, so we're just going to go backwards from our distributive property. So in other words, and I use this very loosely, but we're basically going to factor this. All right, so notice what's going to happen is we're going to pull the first P, or whatever P is, as well as the and we're going to pull it out, and then we're going to be left with Q or R. All right, so hold on to that. And as we go back, this is going to now become, so we're going to pull out, notice the first is the same, so we're going to pull out a not P. We're going to pull out the and this becomes Q or not Q. All right, and that's supposed to be equal to not P. So that's our distributive property, or distributive rule. As long as you say distributive, that's fine. All right, so make sure that you're okay with that. All right, that's a pretty common technique that we're going to be using for our logical equivalencies. All right, so just to show it again, just to make sure that everybody saw that. So we have not P and we have not P and we basically factored that out. All right, and then what we were left with was Q or not Q. All right, so that's the trick with these when you're trying to do these types of distributive properties, is that sometimes you have to go backwards. Now the rest of this is pretty easy. We have Q or not Q. All right, so we're looking for something like that, and I believe we have P or not P, and that's a tautology, so that's our negation law right here. So P or not P. So this now becomes not P and tautology, which is equal to not P, and that's our negation. And then finally, we're hoping that P and T is equal to, or in this case, not P and T is equal to not P. And we go here, and we have P and tautology is equal to P. Let's just replace P with not P, and we're good. That's our identity law. Right? So we're going to say that not P is equal to not P, and that's our identity. Right? And we verified it this time. So remember in the previous example, it didn't work. In this example, it does. All right. One final example of being able to use our logical equivalencies. So this one looks real like it's really ugly. So we have not, and then quantity, quantity, not P and Q, or quantity, not P and not Q, or P and Q, and that's supposed to be equal to P. All right, so this could be really difficult, and it could be really difficult if we started by using De Morgan's law, all right, because we could do that, but let's try to work inside the parentheses first. That might make it a little bit easier. So I'm going to start by noticing that we have a pattern of not P and not P. We have a not Q and a Q, but then we also have like this and or and. And so what we could do is we could just use the distributive property just like we did in the previous. All right, so the first step is we're going to factor, and I use the term factor loosely. So we're going to factor out a not P and we're going to be left with Q or not Q. All right. And again, that's just using, I'm going to flip to the other table. That's just using right here, right? We're just taking this side and we're going here to make it look like the left-hand side, all right? So make sure you understand that. It's a common practice to use when you're doing these logical equivalency problems. We still have the P and Q, and that's equal to P. All right, so that's our distributive property. Our distributive rule. We already saw that Q or not Q is a tautology, right? So, or in this case, P or not P right here. All right, so we have a tautology, so that's helpful. So we're going to say not quantity, P, not P and tautology, or P and Q is equal to P, all right? And that is going to be, I believe, the negation law. So if we look at the negation law, P or not P is a tautology. Right? And P and T, or not P and T, should end up being not P. And I believe that's our identity law. So right here we have our identity law. P and T is equal to P. So in this case, we're going to get not P. All right, remember there's a not in front of that. Or we still have that P and Q is equal to P. All right, so it's our identity law. Double negative is pretty obvious right here. So P and, or excuse me, P or P and Q is equal to P. All right, so that's our double negative. And then let's see if there's something that has the pattern P or P and Q. So we need an or and an and in succession with the parentheses. So we're looking for this pattern. So we go down here. So we have an or, an and. So we have P and P or Q, and that's equal to P. So P and P or Q. And we go back here, we have P or P and Q. And remember, that is equal to P. All right, so just check that out. And so what do we end up with? We end up with P is equal to P. And that's going to be our absorption law. I think that's what we call it. Yep, that's our absorption law. And again, we show that this is valid. Okay, so generally students struggle a little bit when they're doing these logical equivalencies. So if you get stuck with it, make sure you watch the video a few more times, go back, understand the reverse of the distributive property, which usually gives people some trouble initially, but once they get it, and once they've seen it a few times, it's usually pretty easy for them. And then also ensure that you're matching your patterns up with the worksheet. All right, so in the next video, we're going to take a step away from Boolean algebra, and we're going to start talking about conditional statements, and we're going to start talking about the idea of the inverse, the converse, and the contrapositive of our conditional statements.